array. Multiplication fact. Factor.
So if you notice, if you see the multiplication fact, it's highlighting 3 because that is one of the factors. Why do we use an array? How do we use an array in multiplication? Grace?
We use it to like help us multiply.
Yeah, an array can show you a group of 3 rows with 4 in each row. That would show you the factor 3 times 4, right?
How can you find all the factors of a number? Think about this question during the lesson. Three possible arrays of 12 buttons are shown below. The arrays can help find all the factors of 12. 1 times 12, 2 times 6, 3 times 4. What are the factors of 12?
Okay, what factors do you see of 12? Paige? Okay. Those are multiplication facts, but if I'm just asking you for the factors, you would list them. Angie?
1, 2, and 3.
1, 2, and 3 are factors, but there are more. Awesome.
1, 2, 3, 4, and 6.
Okay, there's one more. Grace?
2, 6, 3, 4, 1, 12.
Okay, 2, 6, 3, 4, and 1, and 12. Each of those numbers is a factor of 12.
The factors of 12 are 1, 2, 3, 4, 6, and 12. What other ways are there to show 12 as an array? Flip these arrays on their sides. Other possible arrays are 12 times 1, 6 times 2, and 4 times 3.
Does that change the factors?
No.
Right, the factors remain the same.
What would happen if you turned an array on its side? Would you find any new factors?
No, we just stay the same.
You would find a new multiplication fact, but the factors would stay the same. Would the values still be the same?
Yes.
Yes, the values would still be the same. Let's study these factors further. Arrays can help you find all the factors of a number. However, an easier way is to use divisibility rules.
Okay, so what they're saying is that not always are you going to have access to where you can draw a picture of an array or you have manipulatives to make an array. So an easier way is to use divisibility rules. So right now I want you guys to get out a piece of paper because you're going to take notes on what the divisibility rules are.
A whole number is divisible by another when the quotient is a whole number and the remainder is 0.
Okay, let's read this statement again. A whole number is divisible by another number when the quotient is a whole number and the remainder is the same. Put that in your own words, Brody. What does that mean? When we read that, explain what that means to you. That's why I want to talk about it. So if the whole number is 32, maybe that would help. Let's use an example. And it's divisible by 4 because 4 goes into 32 evenly 8 times, and there's a remainder of 0. So that means that 32 is divisible by 4. Okay, you guys don't have to write anything yet. I'll tell you what you need to write down.
Is 85 divisible by 5?
Yes.
How do we know 85 is divisible by 5?
You can take 85
Hope?
by 5 because when you have a factor of 5, after you, well, when you divide, or when you multiply 5, it always ends in a 0 or a 5.
Okay, so anything that ends in a 0 or 5 is divisible by 5. But we also know that 85 is divisible by 5 because it's a multiple of 5. If we counted by 5s, we would get to 85, right?
It's 7. Yeah.
85 is divisible by 5 because the quotient is 17 and there is no remainder. After viewing this example, let's examine the divisibility rules one at a time, starting with the rule for 2.
Okay, before we go on to those divisibility rules, if a number is divisible by another number, that means it can go into that number evenly without a remainder. So 12 is divisible by 6 because 6 goes into 12 evenly 2 times. 48 is divisible by 8 because 8 goes into 48 evenly 6 times with a remainder of 0. If it's divisible, it means that that number there's an even number of groups. There's 0 remainder. Okay? All right. The divisibility rules are what I want you to write down. So let's start with 2.
2. If the number is even. Example, 48 is an even number. 48 is divisible by 2.
Okay, so you're going to write that down. A number is divisible by 2 if it's an even number. So start right here. 2, if the number is even, then it's divisible by 2.
Wait, 2 if the number is what? Even.
The number is even. This is also in your book. If you happen to get behind, it's in your book.
3. If the sum of the digits of the number is divisible by 3.
Okay. So a number is divisible by 3 if you can add its digits and divide it evenly by 3. So if I add 4 plus 8, what do I get?
4 plus 8 is 12.
12. Can 12 be divided evenly by 3?
Yes.
Yes. So then 48 is divisible by 3. Okay?
4. If the last two digits are divisible by 4. 4 and 8 are divisible by 4.
Okay, so when you're looking to see if a number is divisible by 4, you're going to look at the last two digits. Are those last two digits each divisible by 4, such as 4 and 8? Can we divide 4 divided by 4? Yes. Can we divide 8 by 4 evenly? Yes, it's 2, correct?
5. If the last digit is 0 or 5. 120 ends in 0. 85 ends in 5.
Okay, so we talked about that a little. Anything can be divisible by 5 if it ends in a 0 or a 5, because we know that multiples of 5 end in 0 and 5.
6. If the number is divisible by both 2 and 3.
Okay, so it can be divisible by 6 if you look back at 2 and 3 and both of these are correct. Both of these work. then it's also divisible by 6. So if you have a number that's even and you add them together and it equals a number that can be divided by 3, then it's also divisible by 6, such as 48. 48 is an even number, right? Aaron, is 48 an even number? Okay. If I add the 4 and the 8, that equals 12. 12 can also be divided by 3, correct? It would equal 4. So then I also know that 48 has to be divisible by 6. Are you with me? Okay.
9. If the sum of the digits is divisible by 9, 18 is divisible by 9.
Okay, we know 18 is divisible by 9 because we can say 1 plus 8 equals 9. 9 can be divided by 9. How about 27? If I add the digits of 27, it's 2 plus 7, right, Alex? Is that divisible by 9? So then 27 is divisible by 9. Similar to 3.
10. If the last digit is 0.
Okay, and anything is divisible by 10 if it ends in a 0. So make sure you have these rules written in your notebook.
Using the divisibility rules, is 468 divisible by 9?
Okay, so what do we know about being divisible by 9? If I add those digits and I can divide it by 9, then that number, 468, is divisible by 9. So if we add these digits, what do you get? Lily?
So
Add 4 plus 6 plus 8. 18. Is 18 divisible by 9? Can we take 18 divided by 9? Yes, 18 divided by 9 would be 2. So that means 468 is also divisible by 9. That means if I take 468 divided by 9, I'm going to get a whole number without a remainder. Okay?
Yes, because the sum of 4 plus 6 plus 8 equals 18, and 18 is divisible by 9. What other divisibility rules apply to 468?
What other numbers can we divide 468 by evenly? How about 2? Does 2 work? Is it an even number? Yes. Can we divide by 3?
Yes.
Yes, if we add these up, it's 18. 18 divided by 3 is 6. So this 468 must also be divisible by 3.
Why does it show for the 468 just 4 plus 6 plus 6 plus 8? Why does it just do that?
Say your question again.
Why doesn't for the 468? Why wouldn't it just show 4 plus 6 plus 8 equals 1? So we have to
Because you're deciding whether it's divisible by that number. This is kind of a trick or a rule that helps you know if that number is divisible by those numbers listed. Okay, what about by 4? If the last 2 digits are divisible by 4, is 6 divided by 4 divisible by 4? No, but 8 is, right? But it has to work for both of them, so no, it's not divisible by 4. What about 5? Does it end in a 0 or 5? 6?
Yes.
Yes. 9? Yes, we already did that one. And 10? No.
The other divisibility rules that apply to 468 are 2, 3, 4, and 6.